Character data types are used to store alphanumeric data like words and text in the table columns. In languages like Java or C Sharp, they are called strings. They help us store information like names, addresses, etc. in the database, as well as manipulate character data. They are also used by the database to store table names and column names internally in the dictionary tables, as well as to store the SQL and PL SQL code in the database. Every database is installed with a database character set to support the languages which might be used against the database application, say English or French or Chinese. These are of type char, varchar2, and clob. The Unicode character set is a universally encoded character set which allows us to store different language characters in the database using a single character set, as each language character is given a unique numeric code by the system. So if your application is a global application, it makes sense to make a Unicode character set as the database character set to support globalization. Especially if you're adding a new system, it makes sense to use the Unicode character set as the database character set. Even if your application is not global today, but things can change tomorrow, and having the ability to store characters from multiple languages will give you a competitive advantage in the long run. There is also something called a national character set, which allows you to store in an alternate character set in a database in the Unicode format. The national character set are of type nchar, nvarchar2, and nclob. They are most useful in situations where the database supports, say, English character set, but you want to store French characters in some columns. So you can define these columns as types nchar or nvarchar2 and store French characters over there, while the rest of the columns are of type char or varchar2 and store the default database character set of English. We will talk about the char and varchar2 data types, which are most commonly used. Let us talk about the char and nchar data types. Char is defined as the keyword char followed by an optional size in either characters or bytes. In the case of nchar, you can only specify the size in characters. If you do not specify char or bytes, the database interprets it as the setting of analyst length semantics in the analyst instance parameters table. So here, in this code snippet, select star from analyst instance parameters for analyst length semantics gives us a value of bytes. The maximum size of char or nchar data type is 32,767 bytes. It is better to define the length in terms of characters. That way you tell the database explicitly the number of characters you expect to store in the data type. If you specify it in bytes, you will have to be mindful of the multi-byte character sets where one character may be represented internally, say by 4 bytes. So the maximum number of characters you will be able to store will be the floor value of 32,767 divided by 4 or 8,191 characters. If you do not specify the size, it defaults to 1. Char and nchar are fixed width character types. So if, say, you define a char type with a length of 4, even though the actual value assigned to it may be AB or 2 characters, the database will append 2 trailing spaces to store it as AB space space with a length of 4. In Oracle, the character literals are specified in single quotes as opposed to double quotes in languages like Java and C Sharp. The character type which you would be using most of the time in your applications would be varchar2, which again can be specified using bytes or characters, but unlike char, the size is not optional and you need to specify it. Nvarchar2, like nchar, can only accept the size in characters. These types again have a maximum size of 32,767 bytes. However, one thing to be mindful is that for these types, the database table columns can go to a maximum length of 4000 bytes. And so if your PL SQL code is interacting with the table and storing and retrieving values from it, then you should not exceed PL SQL variable length to be more than 4000 bytes. It is different from char in that it has a variable width and it does not blank pad the data to match the length defined for the variable. So AB will be stored as AB with a length of 2. Thus it is more efficient in terms of storage. Let us talk about the comparison semantics involving character data. If we compare a char with a char, it blank pads them before comparison. So a char with space variable assigned a value of AB space space would be equal to a char variable without space assigned a value of AB without space, when both have a size of 4. However, when you compare a char with varchar2, no blank padding happens for varchar2, and so varchar2 AB is not the same as char AB space space. Note that equal to and not equal to are comparison operators in PL SQL. Equal to is not an assignment operator, unlike some other languages like Java and C#. So some general guidelines for using these character types. Use char only when you require NC compatibility for a comparison and when trailing blanks don't matter. Varchar2 is efficient in storage space. I find myself using varchar2 almost always in my applications.